a few people had asked about questions about the Raspberry Pi and what we actually use them for. And I think if you've seen them but you've never actually used them, it's maybe quite hard to see like straight away where you're going to jump in and what you do with them. So there was a bunch of questions that I know people had asked me that I'd written down. I'm not going to try and like answer them one by one, but I think over this, between the three of us, we'll probably kind of cover the gist of it. So just to start off with, in terms of what it is, I mean, I've got a couple of Raspberry Pis here from ours. I brought them earlier. This was blurring it because blurring my background, but that's one of our Raspberry Pis. We number them. We've got a little SD card. It's a little SD card computer. We've got some other wee gadgets and things that we plug into them. We use Raspbian on it, or Pi OS now. We don't actually use the most recent one just because I hadn't updated them all, but we've got a kind of standard image we put on them all that I'll show in a minute. Some of the kind of programs that we've got. So I've got a couple of little demos here. So this one I just recorded like our desktop that we put on all the Pis. So you can see I've got like a couple of versions of Scratch on there. We've got Thony, which is a really nice sort of clear Python editor. So we use that a little bit with the third years. I've also got Visual Studio Code, which we didn't have on there until recently. I don't use it for Visual Basic, but what I do use it for was the Spike Robotics. So if anybody got the Reason Robots kits, we figured out how we could write Python code using Visual Studio Code on there and load it onto the robots. And I'm happy to share that if anybody's got Spike kits and wants to see how we did it, because it took a wee while. I've got Scratch open there, and I think you can see, like, if I run a little Scratch program. So obviously that's the same as if you were doing Scratch online. But the really cool thing about the Pi is in the extensions. So there's some extensions here for GPIO. So like on the Pi, it's got little pins. I don't know how well that'll come across to see, but you can plug in LEDs and things. You might have bits and pieces for the microbit. You could use the same sorts of things and do some physical computing. And then you can just control that with Scratch blocks. So you could put in a Scratch block to switch on your LED or buzzer or whatever it is. Also in there, though, there's the Sensat. So the Sensat is really powerful. We've only got a couple of them. I would quite like more of a set. But it's got a sort of emulator built in, I guess a bit like what you would do with a microbit. Sorry, just moving a window there. So the simulated Sensat, you can then control in Scratch. It's a little bit like a microbit. It's got a screen, but the screen is in full color. So I've got a physical Sensat there. It's showing when I run the Scratch program, like I'm changing the colors in there in the Scratch blocks. And then I'll get it to scroll a message across the screen. And you can see that that will then run in the emulator. The kids could then run that on a physical Sensat. And I think it's pretty cool. It's quite like it is what's used for the AstroPi. So if anyone's doing that with the European Space Agency every year, the AstroPis are just little Sensats that are stuck on top of a Pi. The other thing that we do with the emulator then, if I open there, it's got some samples in it, just open like a Python example. So our third years had been doing some stuff with that before Christmas, where they were writing little programs using the materials on the Raspberry Pi Foundation website and playing about with temperature sensors and things. It's kind of taken the same idea as the microbit, but taking it a little bit further. And it went down pretty well. It's definitely something that we're going to do again next year. The main thing that I was going to demo, though, was what we've used it for a couple of times in the senior phase that I didn't really expect to use the Pis for. So you can see there I've got a page up about how to set up Apache. And in a minute, I've got a wee demo of like installing the software on for Apache and for SQLite. So in this case, I had some 6 years that we're going to be uploading a website to an FTP server for one of the MPAs. And we thought it'd be quite cool to show them like how you could actually just upload your website on a Pi. So when you install Apache, it takes about a minute to install. I'll show the commands for installing software in a minute. And then you just put your HTML files in this folder. You get the IP address of the Raspberry Pi. So like we've just got a wee local router. It's not connected to the internet, but then the kids could, if they had each other's IP addresses, they could connect and they could like view each other's websites, just sticking the IP address in the browser. And I think it maybe made it a little bit more real for them, rather than just sort of double clicking on the file or running it in Replit. In terms of installing software, I've got here how I installed SQLite. So I'd copied over some database files onto the Pi. And if you bring up the terminal, you can install software if you know what you're looking for. I think this is probably the main advantage of the Pis. You can pretty much install what you want because it's not managed on the network. And however good your kind of council technician side of things are, it's quite easy if you can install software for yourself on the Pi and sort of manage it and then clone that onto 20 SD cards, particularly stuff that's not online. Yeah, Ian's right. You can save £100 every time you install software. So that was just installing a really basic database server on here. We did that when we had some problems. The network was down for a week, but I was able to use the Pis and continue my higher database stuff. So in that little demo there, I'm just browsing for the files, the database files, and then using that database server that I just installed, opening up the database, and that's it there. It's just a command line thing, but I can then type in a little higher query. I think this might be more of a NAT5 level. So I'm selecting everything from the movie database. I made a mistake there. It's just saying there's no such table. I forgot to trim that bit out when I was editing the video. It's just supposed to be movie. So select everything from movie, and you can see there, right, I've got the database output. So it's not Access, obviously, and I know a lot of people are trying to move away from Access. It's not as powerful, but it's pretty quick. And in our case, when we found out the network was going down, we didn't have a lot of time. So I just talked like 17 hires through giving them each a Raspberry Pi and then saying, right, we're going to briefly hotspot it to my phone and download SQLite onto it. And then they were able to carry on with our practical work they were doing. So just kind of in terms of our setup, because I think the other guys as well, we've all got our kind of own ways of doing it, but we got 20 Pis. We got them just before the summer. We've got 2 boxes of 10 because actually we found a Pi and then one kid that's logged into Windows, and then they've got their Google Classroom. It lends itself quite well to pair programming. But we've got 20 of them, and when I've given them to like hires and stuff, then I'll give them one each. I saw there was a question in the chat about how do we organize the software. So yeah, I don't update them all the time, but when we do update one, if I install it onto one SD card, then yeah, I clone it. What I got is just a couple of little SD card readers, plug them into a couple of the Pis, and then it doesn't actually take that long to just run off a whole bunch of copies. They only take like a few minutes each. And I kind of just like do it in one afternoon or something, have it on in the background while maybe I'm teaching. We got the Pi 3Bs rather than Pi 4, and it was just because we could get more of them, and it meant that we could use existing like USB cables and HDMI adapters and things that we had. So we leave them all kind of plugged in. We just give them to the kids when we need them, and then we sort of disconnect them. That's me. I'm just going to hand over to the other guys though, and they'll talk about their setup.
Yeah, so we've been using Pis for a good few years now. Initially, I kind of joked in the Twitter promo, but it's a way of escaping local authority control. But it's true. It can be quite constraining. So having the Pis give us a lot of freedom in some of the things that we delivered. When I first started, we started using these Pi tops. So this is a Pi top, but it's not like the original. The originals were almost like laptops with a built-in Pi. So you had the screen, the keyboard, all built in, and we just gave these to kids, and they ran activities based on it. But when our kids got Chromebooks delivered, we saw it as the perfect opportunity to use these Pi tops. They're battery powered devices, so we can just hand these out to the kid. There's no plugging in, faffing in with keyboards and mice, etc. It's just a case of give this to the kid. They connect it up using their Chromebooks and BNC, and off they go. So there's a couple of activities that we've done. We haven't really embedded it as much as Fraser has, but it's always looking to try and expand it. But some of the activities that we did a hack the smartboard activity. So I connected up a straight Pi to the board and had the pupils. It wasn't really hacking. It was more just some clues to connect via SSH to a Pi, and then change a message on the board. We thought it was great. But the one activity that did kind of take off was using Minecraft Pi. And Minecraft Pi was an activity that I originally wrote for primary kids as a kind of accessible introduction to Minecraft coding, because my nephew asked me a lot about Minecraft modding, so I thought this was a good way of kicking it off. So we started off with 4 activities, which was Hello World, teleporting, volcanoes, and Yellow Brick Road, and then ended up with a TNT brick road after our people decided to change the yellow bricks to TNT. So here's hopefully a wee example of using a Pi to connect to Minecraft. So it is text-based coding, which can be a challenge for primary kids. But effectively here, what I was aiming for was kind of high impact, low code, and these examples really kind of showed it off. With 8 lines of code, I had a TNT brick road, and wherever you walked, it added blocks of TNT, and then you make it explode. It looks great. Kids think it's good fun. The volcano one was interesting. So this is where I got the kids to design a volcano, and then look at X and Y coordinates, and write a little bit of code to place some lava blocks and push them up in a Z direction, so that then they see when they run the code, they see the volcano explode and stuff. So it gives them an idea of how it works. So once we got Chromebooks, it removed a lot of the friction for us in terms of setting up the Pi with keyboards, mice, and screens, and so on. So we used the Pis now for our cybersecurity course in 3rd years, and I get the pupils to SSH onto a Pi, or use BNC if they're not quite so confident in using SSH. So we use the Chromebook to connect it, and we just hand these out at the start of the period. The nice thing about the Pi top was that they can, there's a little screen, and on the little screen it tells them the IP address, so they can connect it up straight away, and there's no need to to give them the IP address or write it on or anything. It's all just basically on the screen. Yeah, and this was our hacking the smartboard task that people had tried the first time round. And as usual, you get some silly messages, but thankfully there was no swear words or anything, so they really enjoyed the task. So I'm not going to keep you all. I'm happy to answer any questions on the chat for the next 5 minutes or so, and then I'll be shooting off if that's okay. I think I'll pass it on to Ian now.
Hi, so I'm talking tonight about Kali Linux, and I'm just going to try and share my screen. It's been a while. Right, here we go. So hopefully you can see that. If you could let me know. That'd be great. Perfect. Yeah. Oh, yeah, just a slideshow. Perfect. Okay, so it's all about Kali Linux. If you don't know what Kali Linux is, it's it's an operating system that's been developed to run ethical hacks and not so ethical hacks on sort of multitude of devices. There's a version for Windows, version for lots of different devices, but there's also a version for the Raspberry Pi. And what we have been doing is for the last sort of 3 or 4 years, we've been sort of building up our NPA cybersecurity course and looking for opportunities to use our Raspberry Pi devices when the sort of the old desktops that are 8 years old and running on hamsters, if they can't manage the task, we try and bring them the Raspberry Pis to do that. It also gives the kids, like Chris and Fraser said, something that's a bit more sort of hands-on. They don't have to read about it or watch a YouTube video. They can actually try and access either their own devices or different devices and sort of make it a little bit more real. So what I'm going to do tonight is just show you a little demo, and it's actually part of the assessment criteria for the NPA level 5. I'm trying to think, it's for the ethical hacking unit. It's not too difficult, but if you've not done it before, it can get quite tricky because you can get lost in that myriad of. It's like what Greg said earlier. HTML was, the bullet point that had to be implemented. For this one, there's so many possible commands in ethical hacking. You can very quickly get lost in a rabbit hole and then end up over teaching it. So I'm going to show you a couple of quick examples that definitely meet that level 5 requirements or part of it anyway. So what we've got here is we've got a Raspberry Pi. We've got a lot of Pi 3 pluses, but I've got tonight a Pi 4. It's an 8 gig Pi 4, but you can do this with a 4 gig Pi 4 as well. And you need an SD card that's 16 gigs minimum. The current Kali Linux image is 9.5 or 9.75 gig to install, so it just doesn't fit onto my 8 gig one. The old ones do, but the very latest one needs 9.75. You can get it from that website, and I use Balena Etcher to image it because I use Windows. So image the, flash the image straight onto the SD cards. And with that one, you can do multiple SD cards at the same time. So this is my setup. So I've been trying for about 8 years to work out how best to make a portable Pi setup, because the pain about Raspberry Pi, as Chris said earlier, is that you got to faff around with cables and keyboards and mice and all these sort of things, but it's the display that has always been the sort of the pinch point for me. And I wanted to have a setup so that the students didn't have to destroy the Windows PC in front of them in order to get the Raspberry Pi working. And I've sort of experimented over the years with different sort of layouts. Like I've stuck the Pis to the back of the monitors and connected them up that way, and that works fine until someone steals it. But this one has actually come about because of some S2 work that we did on e-waste and recycling. And so we had some old Nexus 7 tablets, and we worked out a way, thanks to a few folk from Raspberry Pi, of how to reuse the screen for the Nexus 7 as basically a camera preview. So there's a little HDMI cable in the background there that's connected to the Raspberry Pi. And basically we just trick the Nexus into thinking that we've connected a camera. And it's actually the Raspberry Pi screen. It's brilliant, and it means I can transport it around and power it with a brick, as you can see there. So we've got our Kali Linux, and so we boot up, and you'll see a couple of videos in a second. But the task that I'm going to sort of describe to you tonight is just getting the students to log into Kali Linux. We give them the default username and password, which is Kali. They'll probably change it. That's fine, because we usually give them their own personalized SD card. Then I get them to connect to the local network. Now that could be, like Fraser said earlier, just a non-network, sorry, a non-internet enabled router, which allows all the Raspberry Pis to communicate with each other. I've got it connected to my home network tonight. And then we're going to find the IP address of the device. This is quite a straightforward command once you get used to it, but the students rarely have that knowledge. They know about the graphical way to access the network settings, and they will probably Google what's my IP address to find out the IP address. So we show them how to do that, and then show them how to discover other devices on the network using Nmap. which is one of the sort of key things they've got to demonstrate, and then also see if any of those devices that they found on the network are reachable via their IP address. So we're basically just going to ping that. Okay. So my videos might take a wee second. I was quite annoyed because I broke my phone stand for this, so it's Blair Witch style, I'm afraid. And it's just very short videos. There's no sound. Okay, so I'll just talk over them. But basically, all I'm doing here is I've got my Kali Linux desktop up there. It looks very much like Raspbian, except for the sort of dragon in the background, and I've got the terminal window up there. So the terminal window looks slightly different. And all I'm going to do here is just try and work out what the IP address is now that I've connected to the network. And so it's just the command IP and then space and then the letter A. And you're just looking for the sort of purple, I should have paused that at the end there, looking for the purple, or sort of pinky purple sort of digits there. And so it was 192.168.1.188. So that is the IP address of the Raspberry Pi. And so the students could take a photograph of that, write it down on a bit of paper, depends on how we do that assessment. Okay. Next, we're going to move on to what I find quite cool. I used to use an app on a phone called Fing, F-I-N-G. That's a brilliant one to have if you're teaching cybersecurity or just want to sort of show students what's on the network, because Fing just scans the current network that you're on, and any devices that it can find, it will basically extract as much information as possible about it, even down to like the operating system that's been installed, and display it in a handy little sort of scrollable screen, which again the students can screenshot and use as evidence of, having analyzed the network or done some reconnaissance. So the more technical way to do it is to use this this command called nmap, okay, or this program called nmap. So I'm just going to play the correct video. And you'll see that I'm just typing in nmap at the bottom. I'll try and full screen it, but it's not playing ball tonight. But I'll give you access to this later. So it's nmap, and then we've got some flags. So -v for verbose, and then we put in the IP address of one computer that could be on the network. So just .0. You could have put in .188 at the end, and then /24, and it will scan. I said the 256 IP addresses in that subnet. So it scans for everything. You see there's a lot of hosts down there. That's because the verbose is on. And I can scroll back through those lists. I think I'll do that in a second, and just show you that some of the devices are active and they're returning some information. So this is not a detailed scan. This is just a very quick scan. That's why it runs in seconds. So you can see there that the Kali box is 188, which we found out already. So they should be able to identify that's their computer. And then moving further back through the list, you can see that, that's my router there, 150. And going a bit further back, there's another device, which is the one we're going to look at in a second. So that's the Google Home Mini. So that's on 126. And I think that my printer is somewhere in there as well. But essentially, everything else was turned off for this task. So that's how they discover other devices on the network. And I don't know if you saw at the start there, my command had a sort of little right-hand arrow to an output.txt file. So that basically pipes the output into a file. I didn't do it for the demo there, but you can send the output, instead of to the screen, you can send it to a file, and then you can get the students to either email it to themselves or transfer on a USB drive or things like that. So what I've done in this one is I've just I edited the file, removed all the host down, and I'm just using cat, which basically just displays the contents of the file on the Raspberry Pi. So this will just show us the 4 devices. Okay, so there's our Google Home Mini in the at the top of the screen there. So it's 192.168.1.126. Okay, so as the students are working through this, they're writing down the information, they're gathering that intelligence about what's on the network. And if they did this with a network of Raspberry Pis, they would see each other's Raspberry Pis. So we'd probably talk about renaming their device with the student's name or nickname, so that you could actually identify your friends or your peers in the class. So once they've discovered the devices, the last step is to actually go ahead and try and see if any of them are reachable via their IP address. And so this is where we use ping. So ping basically just sees if the device or the IP address is active and it can send back a signal, or it will accept a signal. So very straightforward. Once you've got the IP address that you want to connect to or test, you just type in the word ping. If you type the word ping in and press enter before you type in the IP address, like I did there, then it's going to kind of come up with an error. And then I'll try it a second time and you should see the result. There we go. So this is the Google Home Mini. It's on the same network, and you can see that it's getting some messages back from the Google Home Mini so that we know that it's active and it's reachable. Okay, and so in that very short series of tasks there, you've seen how you can use Kali Linux to connect to the network. You can get your own IP address, you can see the other devices on the network, and you can test and see if they're actually accepting a connection. And that's just an intro. There's loads of videos like exploring Kali Linux in more detail. And it's not quite fully featured on Raspberry Pi, but it's good enough for NPA level 5, level 6 as well. If you've got any questions, be in the chat and I'm more than happy to answer any. Thank you.